Hey, sorry I'm going to miss this, but you will be taking your Unit 2 formative tomorrow, so today is all about getting ready for that quiz. One of the topics covered in this part of the unit is additive inverse. Additive inverse is a fancy word for opposite, but the technical definition is two numbers when added together that their sum is 0. Well, if you start with a number like 5, you want to think of the number that you can add to 5 where the sum is 0. Well, there is absolutely only one number that you can add to that to get 0, and it's -5. Then, maybe we're going to say, let's talk about the number -100. Well, there's only one number that you can add to -100 to get 0, and that's 100. Well, if you look at the pattern here, when you add two numbers together to get 0, they have to be opposites. So if you drew a picture of the first one, 5 plus -5, you might show something like +5 plus -5. Well, whenever you put a positive and a negative together, they cancel and make 0. So if you put 5 negatives and 5 positives together, you get a sum of 0. You've drawn a picture, you've proven this. In this unit, we introduced new properties, and all of these properties you will grow to love because they give you shortcuts and they make math much more simpler if you use them the right way. The first one is the zero property of multiplication, and what the zero property of multiplication tells you is that 0 times anything gives you 0. We love multiplying by 0 because every single time you get 0. It's easy. The second one is the multiplicative inverse property. Multiplicative inverse is a fancy word for reciprocal. And whenever you multiply a fraction by its reciprocal, watch what happens. If you take 2/3 times 3/2, if you use your cross canceling, you get 1/1 times 1/1, which is equal to 1. It works every single time. The reason why we use the multiplicative inverse, or multiplying by our reciprocal, is because it gives you 1, and anything that's multiplied by 1 keeps its identity or stays the same. So multiplying by 1 is about as easy as multiplying by 0. And the third property is distributive property, and the distributive property looks like this. If you take 5 times x plus 1, remember you're taking 5 times this entire group, so you have 5 x's, which is 5 times x, and then you have 5 of the 1's, and if you have 5 1's, that's the same thing as 5. Remember that you cannot combine those because those are not like terms. You will need to solve about 10 to 12 equations that vary from one-step equations to multi-step equations, and you can solve all of these if you work through them using these 4 steps. First, simplify or rewrite to make it easier. If you have an equation that could be written in a more simple format, do that. For example, if you have an equation that is written like this, n minus -5 equals 10. Just take a minute to rewrite that as n plus a +5 equals 10, and then you can solve it that way. Just makes it a little bit simpler. Number 2, distribute if necessary. Not all of your equations will require the distributive property, but you need to distribute before you solve if it's there. Number 3, use the inverse operation to isolate the variable. Remember that you work through these step by step trying to get that variable all alone on one side of the equal sign. And 4, don't forget to show all of your work. You could get every single one of these equations right with its solution, but if you don't show the proper steps, you will score about a 33% on your formative quiz. So show all of your work. Let's work through a few together. Remember that an equation represents two things that are balanced or equal. So it might be helpful for you to draw a line through the equal sign to remind you that whatever is happening on one side absolutely has to happen on the other side. Also keeping in mind that the whole goal of this is to get your variable by itself. So in this equation, your variable is y. So you work backwards. Get rid of the stuff that's least attached to the variable. In this equation, negative 6y minus 9 equals negative 3. Your negative 9 is least attached to your variable, so get rid of the negative 9 or subtracting 9 first. To do that, you use the opposite or the inverse. The opposite of subtracting 9 is adding 9, or the opposite of a negative 9 is a positive 9. You can think of it either way. If I add 9 on both sides, you have to show this on both sides. You can't just show me adding 9 on the other side, because then it's not truly balanced. A negative 9 and a positive 9 equals 0, and anything added to 0, it stays the same, so it's gone. You've canceled it out. Negative 3 plus 9. Negative 3 plus 9 is positive 6. Negative 3 plus 9 is positive 6. And over here, you are left with negative 6y. Now you have your variable times negative 6, so you need to undo that. To undo multiplying by negative 6, you would need to divide both sides by negative 6. Remember, whatever you do to one side, you must do to the other. And that equal sign stays true all the way down that line. Negative 6 divided by negative 6 is 1, and 1 times y is just y. And 6 divided by negative 6 is negative 1. Now, don't forget that you should never ever get an equation wrong, because you can plug your solution in and see if it works. If you plug in negative 1 up here, you get negative 6 times negative 1, which is 6. So that would leave you with 6 minus 9. 6 minus 9 is negative 3. So you have the exact same value on both sides of your equation, which means that your solution works. Put a box around your answer, and you are done. Here is a multi-step equation that requires you to distribute first. You need to distribute 3 times the quantity g plus 4. So use the distributive property to simplify that. 3 times g is 3g. 3 times 4 is a positive 12. Don't forget about this minus 5g is equal to 6. All you've done is rewrite this using the distributive property. Then look to combine like terms. You have 3g's right here, and you're taking away 5g's right there. If you have 3g's minus 5g's, you are left with a negative 2g plus 12. Now you've used the distributive property and combining like terms to rewrite this as a simple two-step equation. So now use the inverse operation to work backwards to isolate that variable. So the first thing that you would do is subtract 12 on both sides. This cancels out, so I have negative 2g on the left side, and over here 6 minus 12 is negative 6. To undo multiplying by negative 2, I'm going to divide both sides by negative 2. So I am left with g on the left side and positive 3 on the right side. Please remember that you should plug this in and check. If you plug 3 in for g up here, you get 3 plus 4. 3 plus 4 is 7. 7 times this 3 is 21. Then I have minus 5 times 3, which is 15. 21 minus 15 is 6, and that is equivalent to 6 on the other side. So I know that this solution works. Please don't underestimate checking your solutions at the end of each equation. Here is one last equation. There are several different ways that you could work through this equation to isolate your variable. I'm going to show you the quickest way to get x by itself. 4x over 6. To get x by itself, all you would really have to do is multiply both sides by the reciprocal over here. If you multiply this side of your equation by 6 over 4, you can cancel the 6's on top of the fractions, top and bottom, and you can also cancel those 4's. All of those would cancel to be 1, and 1x is just 1. Or sorry, 1x is just x. My bad. But whatever you do to one side, you absolutely have to do to the other. So if I multiply that side by 6/4, I have to make sure and multiply it on the other one. Well, I can still use that shortcut of multiplying by fractions. So I can simplify 4 and 12 both by 4. So that would be 1, and that would become 3. I could also do the same with 6 and 18. I can simplify those or divide those both by 6. So that would be 1 and 3. Now I have 3 on top and 3 on the bottom, which I can also simplify those, and I get 1 over 1. So on this side of my fraction, I have 1 over 1 times 1 over 1, which is the same thing as 1. So 1 is equal to x. If you plug this in, you will see that if you plug in 1 for x, 4 times 1 is just 4. So that would mean that 12 over 18 is equivalent to 4 over 6. And if you would simplify both of these or look for a common factor here, you can divide both of those by 3 and you end up with the same thing. So those are, the two sides of that equation are equivalent. Now that's not the only way that you can solve this equation. You could think of it as using the inverse operation. I'm going to rewrite this equation. 12 over 18 is equivalent to 4x over 6. You could think of this as a division symbol. So the last thing that you're doing to this is dividing it by 6. So to undo dividing by 6, you could multiply both sides by 6. Multiplying both sides by 6 would leave you with 4x. And on this side, it would leave you with, I'm going to simplify this, so that would be 12 over 3, which is 4. If 4 is equal to 4x, you would undo that multiplying by 4, which you would divide both sides by 4, and 4 divided by 4 is 1, and that would cancel, leaving you with x. Either way, you would get the same answer. Now there's a couple of different ways that you can work through this, like simplifying your fractions or using cross products. I can certainly show you those on tomorrow before you take this formative. But here's 2 ways that you could tackle this equation.